So we're going to carry on and we're going to tie together the concepts of VLSM and subnet masking in general into the topic of route summarization. Now, as you get larger and larger networks, your routing tables and your routers can grow to be quite large. And I know some of you might be asking, well, why is this really a big deal? Isn't that what routers are supposed to do? Route traffic from one subnet to another? How is it going to know how to route if it doesn't know about all of the subnets? Well, there's a few reasons why you might not want to have just a massive route table spread across all the routers in your network. First off, large route tables can make troubleshooting difficult. All these IP addresses look the same. Is that a /23 or a /24? Oh, I can't remember. The 10.4 network, is it over here? Is it over there? If they're all listed together, it's kind of hard to remember what network goes to what router unless you've got a map or a diagram. And if you're like most network engineers, your map or diagram is obsolete about 20 minutes after you make it. And again, that's kind of a human problem or an engineering problem. It's not really that big of a deal. Now, the route table itself will overrun the memory more so than the CPU. However, if one subnet on a router goes down, it could possibly trigger a route recalculation across your entire network. Kind of a funny story from my day job. I was in the middle of configuring OSPF, and we don't have that big of a network at my current employer, but we do have a lot of individual host routes for VPN connections. So I configured OSPF, I put the interfaces in the correct area so that it would start receiving routes, and immediately people started walking up to my desk saying, what happened to the network? We can't get to the data center. We can't get to any of the other networks in the enterprise. I checked the router that I had just typed the command on, and because of OSPF calculating all of the paths to all of these various networks, it pegged the CPU on the router and it stopped forwarding packets. And again, that's directly tied to the fact that the route table was so big. For the few locations that we have about 400 entries in our routing table. Of course, this was all my fault. I broke my cardinal rule of not making network changes in the middle of the day, but I honestly thought enabling OSPF wouldn't be that big of a deal. So at any rate, route summarization to the rescue. And quite simply, route summarization takes several networks that can be addressed as a single network range and advertises that large network range to the rest of the network. So essentially, the router says, hey, I know about all of these networks. They're behind me. Anything bound for that network group, just send it to me. I'll figure out where to get it. The net effect of this is that you have smaller routing tables in all of the rest of the routers. Another side benefit of this is if one of those single networks that's behind that router goes down, the summary route back to the rest of the network is not affected, so it will not trigger a route recalculation except on that one router. So again, here's one of my lovely diagrams. You'll notice that we have a network here using all 10.network addresses. We have all Class C networks at our locations. There's 10.110. All the networks that start with 10.2 start over here. All the networks that start with 10.3 are behind network C. Now, this particular layout lends itself very well to route summarization. You notice that all of these networks over here are 10.2. whatever /24. All of these networks are 10.3/24. So you could actually go into each of these routers and configure a summary route for 10.2.0.0/23 in router B and 10.3.0.0/23 in router C. Now, the way you'd come up with these subnet masks for these summary routes is you essentially do the VLSM formula. You remember all that binary magic we did a little while ago. But you do it on the third octet instead of the fourth. In this case, you'd take 23 bits of subnet mask and figure out what the network and the broadcast is for that /23 summary route. A lot of people refer to these as supernets because they cover multiple smaller networks. In this case, the 10.2.0.0/23 route covers all of these smaller networks, these /24 networks. Now, if you were to do that VLSM formula on this particular network and subnet mask, you'd find out that the network is what's listed here, 10.2.0.0. You'd find out that the broadcast is 10.2.3.254. In this case, you'll notice that it covers all of those networks. The same with the 10.3.0.0 summary route down here on router C. Now, you can manually configure this route summarization, or some of the routing protocols will do automatic summarization at classful network boundaries. We'll get into that when we talk about the routing protocols in depth elsewhere in the course. But this PowerPoint deck is mainly just to introduce you to the concept of summarization, what it does, how it works, why you'd want to use it, and we'll get down to the nuts and bolts of how it works elsewhere in the course. But for now, that concludes our discussion of route summarization.